Hey, welcome back. In our last two videos, we focused on finding the inverse of square root functions. Now what we're going to do is find the inverse of quadratic functions. Okay? And when we find the inverse of quadratic functions, in the examples I'm going to give, I'm going to provide a domain restriction. So let's just start with the examples. So here's example 1. And by the way, just remember that the inverse of a quadratic function will end up as a square root function, and vice versa. The inverse of a square root function will end up as a quadratic function. So anyways, here we go. So here's f of x, and this is equal to 2 x minus 1 squared plus 4. And I'm going to provide a domain restriction, which is x is greater than 1. Okay? So here's my first question, which is find the domain and range of f of x. Okay, by this time you should be experts at sketching this. Domain and range of f of x. So remember, step number 1 is always sketch this out. So if we have, let's say, something like this, we know right away the vertex is 1, 4. We know that it's facing up because this is positive. And so let's just draw the entire thing, right? But I also know that this is going to be greater than 1. So of course this is going to be an open circle right here. And since it's greater than 1, I have to erase everything to the left. So I'm going to erase everything to the left. And I'm just going to close this circle over here. So there we go. And then from this diagram, we can determine the domain and range. So the domain is x's element of reals. And we can clearly see, well, that's already given to us. So it's x is greater than 1. And the range, as we can see, y is element of reals. And we can say y is greater than 4, as we can see right here. All right? So that's part A. Now part B is find the domain and range of the inverse. Find the domain and range of f inverse of x. So, well, remember, we can simply use the domain and range of the function to help us out. So the answer here is the domain is x is element of reals, and we use the range. So it's y, oops, not y, but I have to use x. So the answer is x is greater than 4. And the range is y is element of reals. And we can say y is greater than 1 because the domain of the function is the range of the inverse. All right, so this is very useful to us. And now finally, let's do C. C is find f inverse of x, right? So since our function is basically, I'm just going to start writing y and x. So our function is basically this. Y is equal to 2 x minus 1 squared plus 4. Okay? So remember, to find the inverse, the first step that we have to do is switch x and y. So x equals 2 y minus 1 squared plus 4. And then I'm going to subtract 4. So it's going to be x minus 4 is equal to 2 y minus 1 squared. And then what I'm going to do after that is I'm going to divide by 2. So I'm going to do half times x minus 4, and it's going to be y minus 1 squared. And the next thing we're going to do is we're going to take the square root of both sides because I need to get out the y minus 1. So we're going to square root both sides. So I'm going to do half x minus 4. I'm going to square root this side, and I'm going to write plus minus. But what I'm going to say right now is this is going to be temporary. I'm actually going to decide whether it's plus or minus. And we're going to decide that in a second. But first, let's get to it. So y minus 1. And finally, y is equal to plus or minus half x minus 4, the square root, and then it's going to be plus 1. All right, so our next step is actually to determine whether it's going to be plus or minus, because we can't have both. If we have both, it's no longer a function. So let's sketch this. Let's sketch the plus and see what that looks like. So if we sketch the plus, right, we know that our starting point is going to be moved to 4 and 1. So here's 4 and here's 1. There's no reflection. If I just stick with the plus, there's no type of reflection whatsoever. So it's going to look basically like this. And if so we're almost done there. And now if I focus on the minus, right? Let's ignore the plus. Let's focus on the minus. Basically, it ends up with the same starting point, which is 4 and 1. But now that means that's because it's outside the square root, it's a reflection across the y. So it's going to look like that. All right. But however, if I have both of these, we do not have a function. Remember, a function can only, for every x, there's only one y. But let's say, for example, here, for this x right here, we have a y value there, and we have a y value here. So this is not a function. So only one of these can exist. Well, how do we determine which one of these exists? Well, let's look at our domain and range of the inverse. So in this case, we can clearly see that the domain is x is greater than 4, but the range has to be y is greater than 1. Remember, we're looking at the inverse here. So x is greater than 4 and y is greater than 1. So if we look at both of these inverse functions, x is greater than 4 is the same for both. But in this case, only for the top one do we see y is greater than 1. So what I'm going to do is I'm going to erase the bottom one. I'm going to erase the bottom one right there. I'm going to erase the bottom one right there. And again, the reason why I erased the bottom one is because when I looked at my domain and range that I found over here, I noticed that y had to be greater than 1. So when I went back to my inverse functions that I plotted from here, I only kept the one that where y was greater than 1. I erased the other. Well, let's look at the one. Which one is y is greater than 1? Well, it has to be the plus. The reason why it's the plus one is because there's no reflection, right? This is our standard, this almost looks like our parent function, but obviously it's translated. And so this is basically the standard direction of the square root function, so it remains like this. And this is plus, so our final answer is going to be f inverse of x, which is equal to the square root of half x minus 4 plus 1, and this is our answer. I hope that makes sense. And in my next video, I'm going to show you one last example of this.